All right, welcome back everyone for another deep dive. Today we're going to be taking a close look at a technology that's, well, it's really changing the game in the digital world, and that is Ethereum.
Yeah, I mean, most people probably recognize it as that second biggest cryptocurrency out there, but
Yeah.
but that's really just scratching the surface.
Right.
You got to think of Ethereum as this incredibly versatile platform. It's open source,
Hmm.
and it's actually forming the foundation for all these new kinds of internet applications.
Like we're talking about dApps, right? Decentralized apps.
Exactly,
And
that's
smart contracts, those self-executing agreements everyone's so fascinated by.
right, right.
I mean, it's been around since 2015, and you can't deny the impact it's had on, well, how we even think about using blockchain technology in the first place.
Absolutely. It's been huge. And that's really what we're going to be zeroing in on in this deep dive. We're going to move beyond those surface level descriptions, all the technical jargon, and really try to give you a clear understanding of how Ethereum actually works, under the hood.
Yeah, perfect. I mean, I know I'm always curious to peek behind the curtain and see what makes these things tick.
Exactly.
And for this one, we've got some great material to draw from.
Oh, yeah, we've got introductions from BitPay, CoinDesk, Crypto.com University, Forbes, even Invesco.
Wow, that's a pretty wide range of perspectives.
Yeah, so we can really give you a comprehensive view. Think of us as your guides to this whole Ethereum world.
I like that. Guides to the Ethereum world. So let's get started with the basics then, the core of it all. Ethereum is built on something called a decentralized blockchain. Now, I feel like everyone's heard that term, but in the context of Ethereum specifically, what does that foundation really mean? How does it actually work?
Okay, so picture this. You've got this shared digital record book, right? Like a ledger.
Okay, a digital ledger. Got it.
But instead of being kept in one place, it's copied and spread across a huge network of computers.
And those are the nodes, right?
Those are the nodes, exactly. So every single transaction, every bit of activity on the Ethereum network, it gets recorded as an entry in this digital ledger.
Huh, okay.
And here's the crucial part. Every single person on the network, they hold a copy of this ledger.
So it's not just one central authority controlling it.
No, not at all. It's distributed. And once an entry is made in that ledger, once it's verified, it's basically impossible to go back and change it or erase it.
It's permanent, like etched in stone.
Exactly. It's immutable,
So that makes it incredibly transparent then.
incredibly transparent. And because of that, it's also really dependable.
Yeah, no one can just mess with the records.
Right. And that's a big deal when we're talking about trust in this digital world. But maybe even more importantly, it makes the whole system really resistant to censorship.
Because no single entity can control the information.
Precisely.
Wow, okay, so these nodes are playing a pretty critical role then. Can you break down, like, what specific jobs they're doing to keep this whole system running smoothly?
Oh, absolutely. They're kind of like the unsung heroes of the Ethereum network working behind the scenes.
Okay.
And they wear a lot of different hats. First and foremost, they're the gatekeepers. They have to verify every single new transaction, make sure it's legit, make sure it follows the rules.
So kind of like the bouncers at the club.
In a way, yeah. They're also responsible for validating these new blocks of transactions before they get added to the chain, that constantly growing chain of information.
Okay.
And this is huge for how Ethereum actually functions, because they're the ones that execute the code for smart contracts.
Oh, wow. So they're not just validating, they're actually making the smart contracts work.
Exactly. And on top of all that, they're constantly talking to each other, syncing up their copies of the blockchain, making sure everyone's got the most up-to-date information.
So it's all about maintaining consistency across the network.
Absolutely. And since Ethereum switched over to proof of stake, we've got a special kind of node called a validator.
Okay, validators. Tell me more about those.
So validators, they basically put up some of their own ether as a kind of security deposit. We call it staking.
Staking. Okay.
And by doing that, they become responsible for proposing and confirming new blocks on the blockchain.
So they're putting skin in the game to make sure things run smoothly.
You got it.
Yeah.
And if they do their job right, they actually get rewarded for it.
Oh, interesting. So there's an incentive to be a good validator?
Definitely. Now, people always compare Ethereum to Bitcoin, the OG cryptocurrency.
Right.
But how does Ethereum actually differ from Bitcoin in its design and how it operates?
That's a really important question because, well, understanding that difference is key to understanding how Ethereum works.
Okay.
They're both built on blockchain technology, sure, but their main goals, what they're actually capable of, are pretty different.
Right.
Bitcoin was created to be a digital form of money, like a store of value.
It has some very basic scripting capabilities,
Mhm.
but that's about it.
Okay.
A lot of people see it as like pure digital gold.
Just holding its value.
Exactly. Ethereum, from the very beginning, was designed to be way more flexible.
Okay.
It was built to support those smart contracts and apps that we talked about.
Right.
It's got this much more sophisticated programming language that lets people create all these complex features and functionalities.
Hmm. Interesting. So it's like Bitcoin's got a simple calculator and Ethereum's got like a full computer science lab.
Yeah, that's a good way to put it.
So initially they both used proof of work, right?
Right, where miners solve those complex puzzles to validate transactions.
Right. Very energy intensive.
Yes, exactly. But Ethereum went through a huge transformation with the merge back in 2022.
Yeah, that was a big deal.
It switched over to proof of stake, which is so much better for the environment.
Uses way less energy.
Way less energy.
So now you often hear Ethereum called digital oil,
Yeah, because it's fueling this whole ecosystem of applications.
while Bitcoin's still that digital gold.
That's the analogy, yeah.
Okay, I get it. That makes a lot of sense. So we've talked about the decentralized, unchangeable record keeping. Let's dig into what many consider to be the really groundbreaking aspect of Ethereum, those smart contracts. What are these programmable agreements, and how do they actually function within the Ethereum network?
At their core, smart contracts are self-executing digital agreements. It's basically lines of code that automatically carry out these pre-programmed instructions.
Like a set of rules that everyone agrees on.
Right, but those rules are written in code,
Right.
and they only get executed when very specific conditions are met.
So it's all automated.
Completely automated. It's like, if this happens, then do that logic, but embedded directly in the blockchain.
Interesting.
And once a smart contract is deployed onto the Ethereum network, it runs on its own.
So no need for like lawyers or banks to oversee things?
Nope, no intermediaries needed. And that's what makes them so powerful, because it really reduces the need for trust between the parties involved.
You're trusting the code instead of a person.
Exactly. The code dictates the outcome, not some third party. And that's truly revolutionary. It changes how we can create agreements and interact online.
That makes a lot of sense. But can you give us some real-world examples of how these smart contracts work in practice, just to make it a bit more tangible?
Of course. Remember our example of Grandma wanting to send little Billy birthday money every year?
Yeah.
Well, with a smart contract, she could program it to automatically send a certain amount of Ether to Billy's digital wallet on his birthday every single year.
Without her having to remember and do it manually.
Exactly. Or think about renting an apartment. A smart contract could automate the rent payments.
So on the first of the month, boom, the rent is automatically paid.
As long as the tenant has enough funds in their digital wallet, yep. There was even a real-world test by AXA, the insurance company, with flight insurance.
Really?
Yeah, they used smart contracts connected to real-time flight data to automatically pay out if a flight was delayed.
So you didn't even have to file a claim.
Exactly, it just happened automatically. And then you've got decentralized finance, or DeFi, where they use smart contracts for lending and borrowing.
Right, I've heard about that.
And we're seeing them used in supply chains, too, to keep track of goods, making everything more transparent and accountable.
So it's really about increasing efficiency and trust.
Exactly. And looking ahead, there's potential for using smart contracts for secure voting systems, or even fairer ways to pay royalties to artists.
Wow, that's a lot of potential. And Ethereum was the first blockchain to really integrate these smart contracts, right?
That's a really crucial point. Ethereum was the pioneer. They embedded smart contract functionality directly into their blockchain architecture.
That's huge.
It was a game changer. That one innovation is what sparked the explosion of dApps and the whole ecosystem we see today.
It broadened the scope of what blockchains could do.
Absolutely. It went way beyond just simple money transfers.
So now we know what smart contracts are designed to do, but how do they actually run? I mean, that's where the Ethereum Virtual Machine, or EVM, comes in, right? Can you explain what this global computer is and how it operates?
You can think of the EVM as the central processing unit of the entire Ethereum network. Its brain, basically.
Okay.
It's a decentralized environment where all those smart contracts live and work.
And it's called a global computer because
Because it runs consistently
Yeah.
across every single Ethereum node in the world.
So it's not like there's one EVM sitting in a server room somewhere.
No, it's distributed. And its main job is to take the code of a smart contract and process it, following the rules of the Ethereum protocol.
So it's making sure everything runs as intended.
Exactly.
Can you walk us through how the EVM actually executes a smart contract? Like, what are the steps involved when a transaction triggers it.
Sure. So let's say someone initiates a transaction that interacts with a smart contract. Maybe they're sending Ether to a contract,
Yeah.
or they want to trigger a specific function within it. That transaction gets broadcast to the whole Ethereum network.
And then?
Then the EVM on every single node checks that transaction, verifies that it's valid, that it follows all the rules.
So there's a lot of checks and balances.
Absolutely. If the transaction passes muster, the EVM starts executing the instructions of the smart contract.
And those are the opcodes, right?
Exactly, the opcodes. These are very low-level instructions.
Kind of like the basic language that the EVM understands.
Precisely. And as it goes through those opcodes, the EVM keeps track of the computational cost of each step, which we measure in gas.
We'll talk more about gas in a bit, right?
We will. So the EVM also keeps track of any changes to the state of the Ethereum network as a result of this execution.
Like changes to account balances or data stored in the smart contract?
Exactly. Once the execution is finished and all the nodes agree on the outcome, those changes get permanently recorded on the blockchain.
So it's a very collaborative process.
Very much so. And it's important to understand that each node runs its own version of the EVM, so it's like a replicated environment.
To ensure consistency.
Exactly. It makes sure the outcome of the smart contract is valid across the entire network.
Okay, that makes sense. You mentioned these opcodes, these low-level instructions. How does the human-readable code of a smart contract get turned into something the EVM can actually understand?
Well, that's where programming languages like Solidity come into play. Solidity is the most popular language for writing Ethereum smart contracts.
Okay.
Developers write their code in Solidity, which is designed to be, relatively easy for humans to work with.
Right.
But the EVM doesn't speak Solidity directly.
So there's a translation process.
Exactly. The Solidity code has to be compiled into a lower-level format that the EVM can work with.
And that's the bytecode.
That's the bytecode. It can set those opcodes we talked about.
So it's like taking a complex recipe and breaking it down into simple steps that even a basic kitchen appliance can follow.
Yeah, that's a good analogy. The EVM goes through the bytecode step by step, executing each opcode to carry out the instructions of the smart contract.
Got it. Now, to actually interact with this whole system, you need Ether, ETH, and we've heard about gas fees. Can you explain how Ether fuels the network and what these gas fees are all about?
Think of Ether as the fuel that powers the entire Ethereum network.
Okay.
It's the cryptocurrency that's essential for any activity on the platform, whether you're just transferring value between accounts or running a complex smart contract.
Right.
And when we're talking about using Ether to pay for the computational work involved in executing smart contracts and processing transactions, we call it gas.
Gas. Okay.
It's really important to distinguish between Ethereum, which is the platform itself, the blockchain, and Ether, a cryptocurrency that drives it.
Right. Two different things.
Yes, exactly.
So these gas fees, why are they necessary? And how do you figure out how much you have to pay?
Well, gas fees serve a few important purposes. They incentivize the validator nodes to process transactions and keep the network secure.
So they're getting paid for their work.
Right. Gas fees also prevent malicious actors from spamming the network with tons of transactions.
So it's a kind of security measure as well.
Exactly. Now, the cost of gas is measured in something called gwei.
Gwei. Okay.
It's a tiny fraction of an ether.
All right.
And the price of gas, it's not fixed. It fluctuates depending on how busy the network is.
So if there are a lot of transactions happening, gas prices go up.
Exactly. Like surge pricing on a ride-sharing app when it's raining.
Okay, I get it.
To calculate the total gas fee, you use this formula. Gas fee equals units of gas used times the sum of the base fee plus the priority fee.
Okay, break that down for me.
So the base fee, that's set by the protocol itself, and it automatically adjusts depending on how congested the network is.
Okay.
Think of it like the standard toll you pay on a highway.
Okay.
If there's more traffic, the toll goes up.
Makes sense.
Then you've got the priority fee, which is like adding a little extra to get faster service.
Like tipping the toll booth operator to let you through quicker?
Exactly. The base fee takes care of the basic cost, and the priority fee incentivizes validators to process your transaction faster.
Clever. Now, earlier you mentioned different types of accounts on Ethereum. Can you tell us more about those?
Sure. There are two main types. The first is called an externally owned account, or EOA.
EOA. Got it.
These are the accounts that everyday users like you and me use.
To hold and send Ether.
Exactly. They're controlled by a private key, which is like a digital signature that authorizes transactions.
Okay.
The second type is a contract account.
Contract account.
These accounts don't have a private key. Instead, they hold the code and data of smart contracts.
Ah, so they're like the containers for the smart contract.
Yes, exactly. And they can be triggered by transactions from EOAs or even from other contract accounts.
Okay, so you get some ETH to participate in the network. What are the most common ways people actually use their Ether?
Well, there are quite a few ways to use it. First and foremost, you can just use it to transfer value to other Ethereum users, like you would with any cryptocurrency.
Peer-to-peer transfers.
Right. You can also buy and sell ETH on various cryptocurrency exchanges.
So it's like trading stocks, but with crypto.
Kind of, yeah.
Wow.
And you can trade ETH for other digital assets, too, through platforms that facilitate swapping.
So you can diversify your crypto portfolio.
Exactly. Then there's staking. If you're interested in earning passive income, you can stake your ETH to contribute to the security of the network.
And that's through the proof of stake mechanism we talked about earlier.
Precisely. And increasingly, we're seeing businesses, both online and brick and mortar, that accept ETH as payment for goods and services.
So it's slowly becoming a real-world currency.
It's definitely moving in that direction.
Okay, we've covered a lot of the foundational technology here. Let's circle back to those decentralized applications, the dApps. How do they utilize all these mechanisms that we've been discussing?
So dApps are basically software applications that run on a decentralized network, like the Ethereum blockchain.
Right.
What sets them apart from traditional apps, those you find on the web or on your phone, is that their core logic, their data, it's often managed by smart contracts.
Okay.
And this data resides on the blockchain, not on some centralized server controlled by a single company.
So it's all about decentralization.
Exactly. And that makes them much more resistant to censorship, and they're not as vulnerable to single points of failure.
Because the information is spread across the network.
Exactly. Plus, the rules and functionality of a dApp are often encoded in these transparent, immutable smart contracts.
So users can see how the application works.
Yeah, they have more visibility, which builds trust.
Okay, that makes sense. Can you give us some well-known examples of dApps that are currently active and being used on Ethereum?
Absolutely. One of the biggest ones is Uniswap, a decentralized exchange.
I've heard of that.
It lets users trade cryptocurrencies directly with each other without needing a traditional exchange like Coinbase or Binance.
Cutting out the middleman.
Exactly. And Uniswap handles billions of dollars in trading volume every month, so it's a big deal.
Wow, that's huge. What else?
Then there's Aave, a DeFi lending and borrowing platform.
Okay.
Users can lend out their crypto to earn interest, or they can borrow assets by putting up collateral.
So it's like a decentralized bank.
In a way, yeah.
Oh.
Aave also has a lot of value locked within its protocol, so it's a major player in DeFi.
Interesting.
Beyond finance, there are NFT marketplaces where people buy, sell, and trade NFTs, those unique digital assets.
Right. NFTs are everywhere these days.
And then there are dApps popping up in gaming and even decentralized social media platforms.
So the possibilities are pretty broad.
Oh, yeah, there's a lot of experimentation happening. And a lot of these dApps are open source, right?
Right. You mentioned that earlier.
That's a really important part of the dApp world.
Why is that?
Well, because it means the code is publicly available. Anyone can review it, audit it, even contribute to it.
So it fosters collaboration.
Exactly. Developers can learn from each other, find security vulnerabilities, and work together to improve the ecosystem.
It's very community-driven.
Very much so.
You know, we talked about the evolution of Ethereum, especially that transition to proof of stake. Can you tell us why that switch, the merge, was such a big moment for the network and how it changed things?
The merge happened in September 2022, and it was arguably the most significant upgrade in Ethereum's history.
Wow, that's a bold statement.
It really was. It marked the complete shift from proof of work to proof of stake.
And that was mainly to address the limitations of proof of work, right?
Exactly. Those limitations were holding Ethereum back in a lot of ways.
So what are the main benefits that proof of stake brought to Ethereum?
Well, first and foremost, it made Ethereum way more energy efficient.
Which is huge.
Huge. They estimate the energy consumption dropped by 99.95%.
That's incredible.
It was a major step towards sustainability. Secondly, the rate at which new Ether is created, that's been lowered significantly under proof of stake.
Okay.
And because of that, combined with the burning of some of the gas fees, there have actually been times when the total supply of Ether has decreased.
So it's like a deflationary pressure on the currency.
Exactly. And then there's block finalization, a new security feature that makes it way harder and more expensive for malicious actors to mess with the blockchain.
So he's more secure now.
More secure. And while it didn't instantly make transactions faster, proof of stake laid the groundwork for more consistent block times.
Which is important for future scalability.
Absolutely. And lastly, Proof of stake made it easier for people to participate in validating the network.
Because you don't need that specialized mining hardware anymore.
Right, now you can just stake your Ether to contribute to the network's security.
Okay, so speaking of staking, can you explain how that process actually works in this new proof of stake world?
Sure. In proof of stake, we don't have miners anymore, we have validators. To become a validator on Ethereum, you need to stake at least 32 ETH.
32, that's a specific number.
Yeah, it's like a financial commitment showing you're serious about acting honestly and following the rules.
Okay.
Validators are then randomly chosen to propose new blocks of transactions and confirm the validity of other proposed blocks.
So it's kind of like a lottery system.
In a way, yes. And if they do their job properly, they get rewarded with newly issued ETH and a share of the transaction fees.
So it's profitable to be a good validator?
It can be. But if a validator tries to cheat or break the rules, they can be penalized.
They lose some of their stake beef.
Exactly. Now, running your own validator node requires that 32 ETH stake and some technical know-how.
So it's not for everyone.
Right. But there are staking services out there, offered by exchanges and other platforms, that let people pool their ETH together and participate in staking even if they have less than 32 ETH.
So it's more accessible.
Much more accessible.
Yeah.
And they earn rewards proportional to their contribution. That's good to know. And Ethereum's development, it doesn't stop with the merge, right? There's a whole roadmap of upgrades planned.
Oh, yeah. The merge was a huge milestone, but it's just one step in a bigger plan.
Okay.
There are several phases coming up with names like the Surge, the Scourge, the Verge, the Purge, and the Splurge.
Wow. Those are some interesting names.
They're aimed at making Ethereum even more scalable, secure, and user-friendly.
So what can we expect from these future upgrades?
Well, the Surge is focused on boosting the network's transaction speed.
Okay, that's important.
Right. They're going to implement things like shard chains, which basically split the main blockchain into smaller parallel chains.
To process transactions faster.
Exactly. And there are layer 2 solutions, like optimistic rollups, which handle transactions off the main chain to reduce congestion and lower those gas fees.
So it's all about making Ethereum more efficient.
Okay, considering everything we've talked about, all the complexities of its design and operation, what ultimately gives Ethereum its value, and what's the state of its broader ecosystem?
Ethereum's value comes from a few key things.
All right.
First, its network is incredibly robust and decentralized.
So it's resilient.
Very resilient. It's got this huge, geographically diverse network of nodes, so it's very difficult to take down or censor.
Makes sense. What else?
Its supply schedule is dynamic, meaning it takes into account both the new ETH issued as staking rewards and the burning of those gas fees.
So the supply is kind of self-regulating?
In a way, yeah.
Yeah.
And then there's its smart contract functionality, which is incredibly powerful.
Enabling all those dApps and use cases.
Exactly. Ethereum has this vibrant, rapidly growing ecosystem of developers, entrepreneurs, and users.
It's a whole community.
A big one. And it's the foundation for tons of activity in areas like stablecoins, DeFi, NFTs, the creator economy, you name it.
It's really making its mark, but it's not without its challenges, right?
Of course not. No technology is perfect.
So what are some of the key risks and hurdles that Ethereum still faces?
Well, scalability is still a major focus. While proof of stake was a big step forward, the network can still get congested when there's a lot of demand, which drives up gas fees.
Okay, so that's still an issue.
It's something they're working on.
Yeah.
And then there's security. The blockchain itself is very secure, but those smart contracts, well, they're code, and code can have vulnerabilities.
Right.
There have been cases where those vulnerabilities have been exploited, leading to financial losses.
So there's always a risk.
There is. And then there's the whole regulatory landscape around crypto, which is constantly evolving.
That's true. There's a lot of uncertainty there.
It makes it hard to predict how Ethereum will be treated by governments and regulators in the future.
And let's not forget the competition.
Right. There are other Layer 1 blockchains out there and new Layer 2 solutions popping up all the time, offering different approaches, sometimes with lower fees or faster transactions.
So Ethereum has to keep innovating to stay ahead.
Absolutely. And recently, because the network hasn't been as busy, we've actually seen a slight increase in the total supply of ETH.
Interesting. So it's not always deflationary.
Not always, no.
Okay, so let's wrap this up. What are the absolute key takeaways that someone should understand about how Ethereum fundamentally works?
At its core, Ethereum is more than just a digital currency.
Okay.
It's a technology that aims to build a more decentralized internet, where we don't have to rely on centralized
A
authorities.
more trustless internet.
Exactly. It's a platform that lets people create and use smart contracts, those self-executing agreements, and build all sorts of Ds.
Right.
And it's all powered by Ether. It's native cryptocurrency, which incentivizes the validators who secure the network through proof of stake.
And the EVM is the engine that makes it all run.
Precisely.
Yeah.
The EVM executes the smart contracts across a global network of nodes. It's a constantly evolving system at the forefront of the blockchain revolution.
Wow, that's a lot to take in. This has been a truly fascinating deep dive into the inner workings of Ethereum.
It's complex, but it's incredibly exciting stuff.
It really shows that there's so much more to it than just the headlines about cryptocurrency prices.
Absolutely.
And it makes you think about the future, What happens when our digital world is increasingly run by these transparent, automated agreements and applications?
It's a whole new paradigm.
It is. It makes
Yeah.
you wonder what possibilities will emerge and what challenges we'll have to face.
Definitely something to ponder.
It's definitely a topic worth exploring further. Thanks for joining us on this deep dive.